Have you ever stopped to think about what the ice in your drink, the water you're about to sip, and the steam coming off a hot shower all have in common? Well, today, we're going to break down one of the most fundamental concepts in all of chemistry that answers that exact question: the states of matter.
All right, here's our game plan. We'll start with the absolute basics, figuring out what matter even is. Then, we'll dive into the three states you see every day, compare them side by side, and then we'll even take a peek at some of the more exotic states out there. And finally, we'll wrap it all up with why any of this is so important.
So first things first, before we can really get into the different states of matter, we need to be totally clear on what matter itself actually is.
Let's start with a little thought experiment. Just look around you for a second. Think about the phone you're holding, the water in your glass, and the air you're breathing right now. They all seem completely different, don't they? But what is the one fundamental thing that connects them all?
The answer? They are all made of matter. Simple as that. So what do we mean by matter? It's really just two simple rules. If it has mass, you can think of that as its stuff, its weight, and it takes up space, has volume, then it's matter. The book on your desk has mass and takes up space. So does a bottle of water, even the air inside a balloon. It might feel weightless, but it does have mass and it definitely fills up the balloon's volume. It's all matter.
Now here's a really important distinction we need to make right away. There's a difference between types of matter and states of matter. For instance, wood and iron are different types of matter. They're just different substances. But what we're talking about today is how a single substance can exist in different states. And water is the absolute perfect example. Whether it's solid ice, liquid water, or gas we call steam, the actual stuff, the H2O molecules, never changes. The only thing that changes is its physical state.
Okay, so we've nailed down what matter is. Now let's get into the three most common forms, or states, that we bump into in our day-to-day lives.
And here they are, the big three: solid like a rock, liquid like milk, and gas like the air. We're also going to touch on a fourth, super energetic state called plasma a little later on, so stick around for that.
So what's the big secret? What makes a solid different from a liquid or a gas? Well, it all comes down to the tiny, tiny particles, the atoms and molecules that make up everything. The state of any substance is decided entirely by how those particles are arranged and how much energy they have to move around. It's like a microscopic dance that defines the world we see.
Let's start with solids. I want you to picture a perfectly organized classroom. All the students are sitting at their desks in neat rows. They can kind of fidget in their seats, vibrate a little, but they can't get up and wander around. That's exactly what the particles in a solid are like. They're packed together super tightly in a fixed structure. And that's why solids, like an ice cube or a book, have a definite shape and a definite volume.
Okay, so now what about liquids? Imagine the school bell rings for a group project. Now the students can get up and move around the classroom. They can slide past each other, but they still have to stay inside the room's four walls. The particles in a liquid are just like that. They're still pretty close, but they have enough energy to move and flow past one another. This is exactly why a liquid can flow and will always take the shape of whatever container you pour it into.
And finally, we get to gases. You can probably guess what's next. School's out. The students burst out of the classroom and scatter all over the playground, running around freely and randomly in every possible direction. That's a gas for you. The particles have a ton of energy. They're super far apart, zipping around at high speeds and bouncing off each other and anything else in their way. And that's why a gas will always expand to fill any container you put it in, no matter how big. Okay, that classroom analogy should give you a really clear picture of what's happening at the particle level. So now, let's get a little more formal and put the properties of solids, liquids, and gases right next to each other to compare.
This table sums it all up beautifully. Let's just walk through it. First up, shape. A solid holds its shape, right? But liquids and gases, they'll take the shape of their container. Easy enough. Next, volume. A solid and a liquid both have a fixed volume. A gas, on the other hand, has no fixed volume. It just expands. Then we have compressibility. Because the particles in solids and liquids are already packed in pretty tight, you can't really squeeze them any closer. But a gas, with all that empty space between particles, you can compress it easily. Think about pumping air into a bicycle tire. And finally, all of this is explained by what we call intermolecular forces. Basically, how much the particles attract each other. Those forces are super strong in solids, a bit weaker in liquids, and practically non-existent in gases.
Now, you might be thinking, okay, solid, liquid, gas, got it. But believe it or not, that's not the whole story. Let's take a quick detour and look at some of the other, more extreme states of matter.
First, we have plasma.
And no, this has nothing to do with blood plasma. This is what scientists call the fourth state of matter, and it's actually the most common state in the entire universe. So what is it? Well, imagine you take a gas and you heat it up to insane temperatures, like sun-level temperatures. The energy gets so intense that it actually starts to rip electrons away from the atoms. What you're left with is this supercharged, glowing soup of particles. That's plasma. Then you've got these weird intermediate states. These are things that just don't want to be put in a box. Think about something like slime or jelly. Is it a solid? Is it a liquid? It's kind of both, and that makes them really fascinating to study.
Whew, okay, we have covered a lot of ground today. So let's bring it all home. Let's recap the most important points and think about why understanding all this stuff is so crucial.
All right, so if you take anything away from this explainer, it should be these key ideas. First, all the physical stuff in the universe is matter, and it's all made of particles. Second, the state of that matter, whether it's a solid, liquid, or gas, is all about the arrangement and the energy of those particles. Remember, you can usually change the state of something just by adding or taking away energy, which we usually do with heat.
And that brings us to one last big question to think about. When you look at our world, we build our homes and cities out of solids. We depend on liquids like water to survive, and we're protected by the gaseous atmosphere we breathe. So, knowing that it's all just particles arranged in different ways, which state of matter do you think is truly the most essential to our existence? There isn't a single right answer, of course, but it's a fascinating thing to consider. Thanks for joining me for